In the final years of World War II, as the conflict consumed entire continents, a new kind of warfare was quietly taking shape, not on the ground, not in the air, but at the very edge of space. While bombs fell over Europe and cities burned, a small group of engineers began working on something that seemed impossible, even by today's standards. A weapon that would leave the atmosphere, a machine that would travel across the curvature of the Earth, a bomber that could strike targets on the other side of the planet in a matter of minutes. This was not science fiction. This was the Silbervogel, the silver bird, a concept so far ahead of its time that even modern aerospace engineers still study its design. But how close did it come to becoming reality? And what would have happened if it had succeeded? To understand the Silbervogel, we need to go back to a time when Germany was losing the war. By the early 1940s, the strategic situation had begun to change. Germany, once rapidly advancing across Europe, was now facing pressure on multiple fronts. The Soviet Union was pushing from the east, the Western Allies were preparing for invasion from the west, and most importantly, German cities were being bombed relentlessly. Night after night, waves of bombers crossed the skies, dropping thousands of tons of explosives. The war had reached German soil, and with it came desperation. Germany needed a way to strike back, not just tactically, but psychologically. A weapon that could hit the enemy where they felt safe, even across the ocean. This is where the idea of long-range strategic bombing became crucial. But there was a problem. Germany did not have a reliable bomber capable of reaching the United States and returning. The distances were simply too great. Traditional aircraft could not carry enough fuel, and even if they could, they would be vulnerable, slow, detectable, interceptable. What Germany needed was something entirely different, something faster, higher, untouchable, something that didn't really exist yet. The concept of the Silbervogel was developed by Austrian engineer Eugen Sanger alongside mathematician Irene Brett. Their idea was radical. Instead of flying through the atmosphere like a normal plane, the Silbervogel would use it as a surface, like a stone skipping across water. The craft would be launched at extremely high speed using a rocket-powered sled along a massive rail system. Once airborne, its engines would ignite, pushing it to hypersonic speeds far beyond anything that existed at the time. Eventually, it would climb so high that it would reach the upper layers of the atmosphere, almost space. But instead of entering orbit, the Silbervogel would begin a series of controlled descents. Each time it dipped into the atmosphere, it would generate lift and bounce back up again, skipping, gliding, traveling thousands of kilometers with each arc. This technique is now known as skip-glide flight, a concept still being explored today. In theory, the Silbervogel could travel from Europe to North America in a single mission. It could carry a payload of explosives, strike a major city, and then continue its trajectory, eventually landing in a controlled zone, possibly even in the Pacific or Allied territories, or perhaps not returning at all. The implications were enormous. For the first time in history, a nation could strike across continents in minutes, not hours, not days, minutes. And there would be almost no warning, no interception, no defense. At those speeds and altitudes, the Silbervogel would be nearly impossible to stop. But the idea came with a problem. Actually, many problems. The first was heat. At hypersonic speeds, air friction generates extreme temperatures. Even modern spacecraft must deal with this during re-entry. The Silbervogel would have faced these conditions repeatedly, with each skip. Engineers estimated that temperatures could reach thousands of degrees Celsius, hot enough to melt most metals. At the time, there were no materials capable of withstanding such stress. The second problem was guidance. This was before modern computers, before GPS, before advanced navigation systems. Piloting a craft across thousands of kilometers at extreme speeds, while leaving and re-entering the atmosphere, would have required precision beyond what was technologically possible. A small error could mean missing the target by hundreds of kilometers, or worse, losing control entirely. The third problem was the launch system. The Silbervogel required a massive rocket sled, running along a track several kilometers long. This system would accelerate the craft to incredible speeds before takeoff. Building such a structure during wartime, under constant threat of bombing, was a challenge in itself, and once built, it would be an obvious target, impossible to hide, impossible to move. Then there was the issue of fuel. Rocket engines, powerful enough to sustain hypersonic flight, would consume enormous amounts of propellant. Every kilogram mattered. Every inefficiency could mean failure. Despite all these challenges, the concept was not entirely dismissed. In fact, it was taken seriously. German authorities reviewed the design, calculations were made, wind tunnel tests were considered. For a brief moment, it seemed like the Silbervogel might become reality. But as the war progressed, priorities shifted. Germany was running out of resources. Factories were being bombed. Fuel was scarce, and the front lines were collapsing. Projects that required massive investment with uncertain outcomes were increasingly difficult to justify. The Silbervogel was eventually abandoned, left on paper, a concept ahead of its time. Too ambitious, too complex, too early. But the story does not end there. After the war, both the United States and the Soviet Union captured German scientists, engineers, and documents. They were eager to understand and replicate advanced technologies. Among these documents were the plans for the Silbervogel. American researchers studied the concept, Soviet engineers examined its feasibility, and while they recognized its potential, they also confirmed its limitations, at least with the technology of the 1940s. However, the ideas behind the Silbervogel did not disappear. They evolved. Decades later, similar concepts began to appear. Hypersonic glide vehicles, spaceplanes, re-entry vehicles that skip along the atmosphere, technologies that echo the original vision of Sanger and Brett. Even today, countries are developing weapons capable of traveling at hypersonic speeds. Vehicles that can maneuver at the edge of space, difficult to detect, hard to intercept, and devastating. If used, in a way, the Silbervogel was not a failure. It was a beginning, a glimpse into the future of warfare. But there is another side to this story, one that is often overlooked. Some historians have speculated about the intended targets of the Silbervogel. One of the most discussed scenarios involves New York City, a transatlantic strike, a demonstration of power, a message. But what would have been the consequences? At those speeds, even a relatively small payload could cause significant damage. The kinetic energy alone would be immense. And if the craft carried conventional explosives, the destruction could be severe. But perhaps more important would have been the psychological impact. A weapon that could strike from across the ocean without warning would have changed the perception of distance, of safety, of war itself. And yet, it never happened. The Silbervogel remains one of the most fascinating what-if scenarios of World War II. A machine that blurred the line between aircraft and spacecraft, a concept that seemed impossible. And yet, was mathematically sound. It raises a question, not just about the past, but about the future. How many ideas today seem impossible, only because we lack the technology to realize them? And how many of those ideas will become reality in the years to come? The Silbervogel was never built, never tested, never used, but its legacy may still be flying above us.